The vertex of a graph is the point at which the line changes direction. In this instance, the vertex cannot be below the x-axis or 0 on the y-axis. Since this is an absolute function, the vertex will not be able to go below 0 since an absolute value function cannot be negative. You can see this in real life when the light bounces off the mirror and back onto the graph. The vertex of our line is on -2, 1. As you can see on our graph, the light beam is much shallower than the parent function for absolute value. In fact, it is half as steep as the parent function. The function is also shifted 2 units to the left and 1 unit up. The beam can be represented by the equation f of x equals 1/2 x plus 2 plus 1. The variable of h shifts the vertex left 2 units, the variable of k shifts the vertex up 1 unit, and the variable of a is shorted by a vector of 1/2.
The form of our function would be f of x equals 2, open parentheses, x plus 2, close parentheses, plus 1. Because when you graph our function, it is 2 to the left, and then we move it up 1 for the plus 1. And it is slightly steeper, so we had it as 2. Is negative infinity to positive infinity because on the graph the lines from the function go all the way infinitely out to both sides.
The absolute value function is the number of its distance from 0 on a number line or a graph. The absolute value parent function is written as f of x equals the absolute value of x. In this case, x would have to be greater than 0 and y would have to be greater than 0. Given for our graph, we translated the graph into our domain, which is -2, and our range of -1 to be in our vertex. Now for our range of our graph, the range is the difference between the lowest and highest values in the y-axis. For our range, we chose -2 to positive infinity, and then -1 to positive
symmetry is represented on a graph when a vertical line divides the shape into 2 congruent parts. For instance, within our graph, we're showing an example of an absolute value when using a flashlight and a mirror. When we shine the light onto the mirror, it then reflects and bounces off the mirror, giving it into the different direction. Zeros is represented for the values that make the function equal to 0. Zeros intercept the function of their x values for our function to cross the x-axis.